All right, what's up developers? This is part 3 of the D3 React and TypeScript tutorial, and in this video we're going to learn about scales. So let's go ahead and get started. We're going to render an SVG, and let's make the SVG a little bit bigger. So we're going to give it dimensions of 800 by 500. Okay, we're going to bring in a ref. Make sure you import it. And we're going to have a selection state. Okay. And we are going to bring in use effect. And we're going to have selection in our dependency array. And we're going to write a conditional. If the selection has not been set, then go ahead and set the selection to the D3 selection. Ref.current. And let's go ahead and satisfy the types. And we're going to copy this really complex type right here. And the selection will either be null or the type that we just copied. Okay, and make sure you're importing selection from the selection type from D3 selection. And cool, we have everything satisfied. All right. For this, we're gonna go ahead and add these libraries: D3 scale and the corresponding types, and D3 array, add types, D3 array. I already have it installed. You can go ahead and install that now. Okay. All right, so let's talk about scales. Okay, now what if we had data with numbers so large or so little that it wouldn't be optimal to represent them in pixels? Like say, for example, we have some financial data of some company and some of the numbers were in the millions, right? Obviously, just straight up passing that number as the height of the bar would be ridiculous, right? And this is exactly the problem that scales solve, right? So let's go ahead and create some mock data. And let's give it some nice number, nice big number, okay? Interesting how I did that. And didn't highlight the rest, but whatever. Okay. And let's go ahead and give it some random numbers in the thousands. I'm just rolling my fingers across the keyboard. Oh, that's a little too big. Okay. All right, so let's go ahead and add in the scale. It's called scale linear from D3 scale. Okay, and let's go ahead and make that scale. And how we do that is by saying constant y equals scale linear, and we just call scale linear. Okay, linear scales help scale numbers from a given domain to a given range. And by default, the domain and the range is between 0 and 1. But what if we wanted to specify the domain and the range? We can say domain, and we can say range. And what they accept as arguments is an array. And with the first element of the array being the floor, and the second element of the array being the ceiling. So in this case, since our highest number is, say, 9,000, we're just going to say between 0 and 1,000 for good measure. And 10,000, sorry. Okay. And for our range, since we have a height of 500, we're going to go ahead and say between 0 and 500. All right, so let's go ahead and console log some of these numbers out. Whoops, that is not what I want to copy. And let's go ahead and write some numbers. Okay. All right, cool. As you can see, we scaled down our numbers so we can use these numbers to indicate the height of our rectangles, right? So if we have a domain value of something like 2,305, we can have a rectangle height of 115. Okay, so let's go ahead and build some of these rectangles. Comment this out. We have a selection. We're going to select all the rectangles. We don't have any yet, but we will when we append them. We're going to join our data. And we are going to go into our enter selection. We're going to append our rectangles. Whoops. Okay, and we're going to give it some attributes. .attr, we're going to give it, we're just hard code 100. We're going to space it out the same way we've been doing before, underscore I times 100. We're going to give it a fill color of, say, orange. And we are going to give it, this is where we're going to utilize our linear scale, right? So we have our height. Say if we put d dot number, obviously that's not going to look very good because the number is so large, right? So we're going to scale it down. Okay. And something went wrong. Let's go ahead and see if we can look what happened. Obviously, wow, we didn't even assign the ref. Cool. All right. Yeah, so there you go. Okay. Okay, so say we want to scale out our bars, our rectangles throughout the width of the SVG, right? Now, band scales actually help with this. Linear scales don't. So we're going to import a band scale. Okay, and we are going to say x equals scale band. Okay, so what scale band or band scales do is they divide the range into uniform bands and will map it into the domain. Okay, so they accept an array, or sorry, the domain accepts an array of unique identifiers that represents our data, so that later when we input these identifiers, it will help, it will output for us where along the x-axis it should be placed, in which, in this case, we'll be using the name. All right, and how we do that is by doing this. Okay, so that later when we input the name of the data, it will tell us how far along the x-axis it should be. So the range will be how long the x-axis is, or the width of the SVG, which is 800. So let's go ahead and say 0 to 800. All right, and instead of spacing it out like this, we are going to give d and x d.name. All right. Now the reason why Typescript is complaining is because it's possible that this can actually return undefined, and what attr wants is the value and null, not undefined. So we're having a null and an undefined mismatch. So let's go ahead and we can solve that by saying writing a conditional by returning if, say, let's go ahead and capture that for const x value equals x d.name. if x value exists, let's go ahead and return x value. If not, return null. Okay, and there we have it satisfied. Or if you're certain that you're not going to run into any errors, we can just bang it. Okay, and what this bang does is actually just tells Typescript to ignore it, that we know what we're doing. Okay, cool. So you can see now it's evenly spaced out, right? The band scale actually provides us with the width too, and it's in a property called bandwidth. So let's go ahead and write it, x.bandwidth. And there you have it. It's evenly spaced out and has nice widths as well. Okay, so let's say we want some padding. We do actually want some padding, right? So we can actually specify padding in our scale, in our band scale, right? And it accepts a number between 0 and 1. The closer it is to 1, the more padding you'll have. The closer it is to 0, the less padding you'll have. All right, so let's go ahead and say we want some really big padding. All right, what's wrong here? Okay, all right, sorry. So we have lots of padding here. And let's go ahead and give it less padding. All right, the closer it is to 1, the less padding you'll have. All right, so what if we want only the padding inside and not the outer, not outside the bars, right? So we can actually specify that saying inner, right? And if we do want some padding on the outside, and let's say we want lots of padding on the outside, we can say 0.87, right? And it will pad a lot on the outside. Okay. All right. Now in our domain for our linear scale, we have specified that it to be between 0 and 10,000. But what if our bar chart is varying all the time? Like it's updating, and removing, and adding in data. Obviously, hard coding a domain is probably a bad idea, right? So we can use the max function in D3 array. In which we can give it an array and a function, and it will compare to see which is the max value. So let's go ahead and say constant max value equals max. I'm pretty sure Lodash has a similar method or function. And we pass in data as the first argument, and we pass in the value as the second argument. So d dot number, and it will tell us. I'm sorry, what's happening here? Did I not import max? Oh, interesting. I was freaking out. All right, d dot number, okay? And it will basically tell us which is the max here, which is basically 9,000, right? And we can say max value here. Okay, now Typescript is again complaining, and it's because max returns a value or undefined. So I'm just going to bang it, since I know that there's going to be a value given. And you can see that it's maxed out. All right. Cool, there you have it. Those are scales. Next up, we're going to be talking about groups and margins. All right, see you there.